Hello neighbor, this is Tom from TutorBros. Today we're going to go over how to simplify cubic, fourth, and fifth root radical expressions. Now in a previous video we learned how to simplify square root radical expressions, so if you haven't seen that, please check it out, because the process that we're going to cover in this video is almost identical. The only difference is that when breaking down non-square root radical expressions, we're going to be looking not for the highest perfect square factor, but instead the highest perfect cube or fourth or fifth factor, depending on the root of our original radical expression. Yet again, I feel like I've gotten ahead of myself, so let's take a step back and do a couple example problems together. So if we look at number 1, we are trying to simplify the cubic root of 54. So again, instead of looking for the highest perfect square factor, we're going to look instead for the highest perfect cube factor. So what would be the highest perfect cube that goes into the original radicand of 54? Well, I'm going to go through them in my head. I'm thinking about it, and if I go through all the factors of 54, I think the highest perfect cube factor would be 27. So I'm going to break up the original expression into two new expressions. I'm going to say the cubic root of highest perfect cube, again, is 27 times the cubic root of, and then the way to find the second expression would be to ask ourselves, okay, how many times does 27 go into the original radicand 54? And that would be 2 times. So we can say the cubic root of 2. And then again, the purpose of doing it this way would be to simplify the perfect cube expression. So namely, that would be the cubic root of 27 here. If we take the cubic root of 27, that's just going to give us 3. So then we can rewrite this one more time as 3 times the cubic root of 2. And then we can't break down that second part because there's no rational number equivalent to the cubic root of 2. So we can just leave it as is like that. So it'd be 3 times the cubic root of 2. Okay, let's try another example together. We'll do number 2 now. This will be a fourth root expression, and we've also added a variable in there. So now we have the fourth root of 48a to the fourth. So how do we simplify this? Well, now we're going to be looking for the highest perfect fourth factor of 48a to the fourth. So I'm going through all the factors of 48 in my head. If you need to write them down to help you, that's fine. So I think the highest perfect fourth factor of 48 is going to be 16. So I'm going to write fourth root of 16. But I'm not done yet finding the largest perfect fourth factor because we also have a variable here, namely a to the fourth. Now a to the fourth is itself a perfect fourth because the exponent is divisible by 4. So that's how you can tell that it's a perfect fourth. So I'm going to include that in my highest perfect fourth factor. So it's going to be 16a to the fourth. And then we multiply that by the fourth root of something else. Now, what is that something else? Well, then we say, okay, 16a to the fourth, how many times does that go into the original radicand of 48a to the fourth? And I'm thinking about it, and that's going to be 3 times. So we can say the fourth root of 3. And then last step, again, we simplify. What is the fourth root of 16a to the fourth? Well, the fourth root of 16 is 2. And the fourth root of a to the fourth, we would just divide the exponent by the fourth root. So 4 divided by 4 is just 1. So it'd be a to the first, or just a. So we can rewrite that first expression as 2a times, and then the second expression, can't simplify that any further. That's going to stay the same. It'll be the fourth root of 3. So our final answer here would be 2a times the fourth root of 3. Okay, last but not least, we'll do a fifth root expression, and this one also has some variables in it. Okay, so now we have the fifth root of 96, a to the 7th, b to the 11th. So this is going to take a little bit more work than the previous two. So what is the largest fifth root factor of the radicand, 96, a to the 7th, b to the 11th? Again, I would encourage you, if you need to write out all the factors of 96. The highest perfect fifth factor of 96 is going to be 32. So when we're writing out our highest perfect fifth, it's going to be the fifth root of 32. And then we have to take a look at each of the variables in turn. So a to the seventh. Now that is not a perfect fifth, but what is the highest perfect fifth that goes into a to the seventh? Well, I think it would be a to the fifth. So there is a to the fifth, and then we would have two more remaining to get to a to the seventh. So a to the fifth would also be part of our perfect fifth. And then how about b to the 11th? Well, so what number that doesn't exceed 11 is a multiple of 5, and thus a perfect fifth? So we could do b to the fifth, but I think we can go even higher. We could do b to the 10th, because 10, again, is a multiple of 5. So let's do a to the fifth, b to the 10th. So that would be our largest perfect fifth factor. Okay, and then we say, okay, how many times does 32, a to the fifth, b to the 10th go into 96, a to the 7th, b to the 11th? Well, 32 goes into 96 3 times. So let me start writing this out here. So it's going to be multiplied by the fifth root of, so 32 into 96 is 3. And then how many times does a to the fifth go into a to the 7th? Well, we would have to multiply by a to the second. So that would be a to the second here. And then b to the 10th into b to the 11th. Well, how many b's are left over to get from the 10th to the 11th? We would have to multiply by b to the first, or just b. Okay. So the second expression here would be the fifth root of 3a squared times b. And then we can write our final answer by simplifying the perfect fifth factor by taking the fifth root. So the fifth root of 32 would be 2. The fifth root of a to the fifth, so again, we just take the exponent and divide by 5. So 5 divided by 5 is 1. So that would just be a to the first, or a. And then b to the 10th, take the fifth root by taking the exponent, divide by 5. So 10 divided by 5 is 2. So 2ab squared times, and then multiplied by the second expression, which we can't simplify. So fifth root of 3a squared b. So our final answer here would be 2a squared b times the fifth root of 3a squared b.